All right, algebra. So adding and subtracting expressions with common denominators today. Operations with rational expressions follow the same rules as operations with rational numbers. Expressions with a common denominator are added by writing the sum of the numerators over the common denominator. Be sure to simplify the resulting expression. So example number one, this is both A and B are more what we are used to seeing. All right, so we have 4 over x plus 9 over x, common denominator of x. So all we have to do is add our numerators. So the answer to that one would just be 13 over x. Okay, in terms of part B, again, we have the same denominator of 15. And in our numerators, we have 2a and 8a, so we can just add those. They are like terms. 2a plus 8a gives us 10a over 15. I am not done yet because that is not simplified. Both 10 and 15 are divisible by 2, so that's going to be, no, they're not divisible by 2. They are divisible by 5. 10a, so 10 divided by 5 gives me 2a. 15 divided by 5 gives me 3. Okay, so 2a over 3 is the answer to that one. All right, example number 2, common denominator of x minus 4. So we can just jot that down there as our denominator. And then we're going to do 2x plus 9 plus 3x plus 6 in our numerator. Look for your like terms, 2x and 3x, 5x, 9 and 6, 15 over x minus 4. Okay, now this we want to factor. Okay, we want to factor just to make sure that we can't simplify this at all. All right, so factor the numerator. 5x and 15, both 5 and 15 are divisible by 5. So I'm going to factor out the 5, leaving you with x plus 3 over x minus 4. That shows me there's nothing that I can cancel, so this is as simple as this gets. There we go. Example number 3, we have a common denominator of x plus 2, so our numerator, we have 3x squared plus 4x minus 8 plus x cubed minus 3x minus 6. What we're going to do is we're going to add the numerators first. We're going to add all our like terms, and then we're going to see what we can factor. So 3x squared plus 4x minus 8 plus x cubed minus 3x minus 6 all over x plus 2. I'm just writing that denominator in there so I don't forget to do it later. When you're just working on adding up your numerator, though, you don't necessarily have to, but I would hate for you to lose track of it. So now look for our like terms, okay? There is, and you know what, I wrote that wrong. Sorry, it's not x cubed, it's x squared. So I have 3x squared and I have x squared. Remember, there's a 1 there. We just don't write it. So that's going to give me 4x squared when I combine those like terms. And sometimes when I have multiple terms like this, I just like to cross them out as I go to make sure I don't lose track of anything. And then I have 4x minus 3x. So that's just going to give me x. And then I have negative 8 minus 6 is going to give me minus 14. That's all over x plus 2. Okay, now I want to factor. Okay, I want to factor 4x squared plus x minus 14. That's going to factor to 4x minus 7 times x plus 2 all over x plus 2. I can write parentheses around there if it makes me visualize this a little easier. That cancels out, and I am left simply with 4x minus 7. I'm not writing that right now because my iPad pencil just died. So the answer to that is 4x minus 7. I'm going to stop this recording, and I will come back and add a little bit in a minute. All right, so, whoops. Final answer to this one, 4x minus 7. Now, quick side note. I did not spend any time right there working through factoring out 4x squared plus x minus 14. I'm not going to spend time working through how to factor things, okay? If you are struggling with factoring, you've got to go back to chapter 10, okay? Go back and look at chapter 10. 10.5, the very end of 10.5 has that chart kind of that you work through, basically like choose your own adventure. If it's this type, go through these. If it's this type, go through these kind of deal. And there are videos still on my YouTube on factoring. So if you are struggling with factoring, again, I'm not going to spend time factoring these things out on these lessons. You need to go back and do some review. If you are still struggling, please reach out to me because it's huge, 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 huge as we move through this chapter. So if you're struggling, reach out to me privately, but I don't want to spend a ton of time on these lessons working through that. So there is my side note. Now, example number 4. Example number 4, we have a common denominator of 8x, okay? And we are subtracting this time, So we end up with 2 plus x minus x. Now we have a subtracting a negative 8, subtracting negative 8 over 8x. So really what we have, 2 plus x minus x plus 8 over 8x. If there's anywhere that you guys are going to make mistakes in here, it's on stuff like that. All right, so x minus x, those x's obviously are going to go away. All we have left is 2 plus 8 is 10 over 8x. That is not simplified. Both of those are divisible by 2, and we get 5 over 4x. Now, example number 5, 3x squared plus 3x minus 20 minus x squared plus x plus 4, okay, over common denominator. 3x squared plus 3x minus 20. And I'm just going to put parentheses around that whole thing so we can keep track of what's happening when we subtract this. All over x squared plus 9x plus 20, okay? So look for your like terms. We have 3x squared minus x squared, okay? 3x squared minus x squared. So 3 minus 1 gives me 2x squared. Then we have 3x minus x, right? This is minus, okay? So 3x minus x gives me a positive 2x, 3 minus 1. Those are gone. And then I have negative 20 minus 4, okay? Negative 20 minus 4. So that is negative or minus 24 all over x squared plus 9x plus 20. Now I'm going to factor both the numerator and the denominator so that I can see where I can cancel. The top one is going to factor to 2 times x plus 4 times x minus 3 all over x plus 5 times x plus 4. And I said the top one, the numerator, okay? X plus 4, that's going to go ahead and cancel out. All I'm left with in my numerator is 2 times x minus 3, and in my denominator, x plus 5. There is nothing else I can do to simplify, and we are all done. I just took a picture of the rest of this page 544, and popped it in here. So I'm just going to read through it. First of all, adding rules for adding and subtracting rational expressions with common denominators. Number 1, add or subtract the numerators. Number 2, simplify, right? Very straightforward. Now, a rational number can be thought of as having 3 signs, 1 in the numerator, 1 in the denominator, and 1 preceding, coming before the fraction. The rational number, this, negative 4/5, can be expressed as any one of these 3 equivalent expressions. So negative 4/5, that's that preceding the fraction idea, okay? Or we could have negative 4 over 5, or we could have 4 over negative 5. It is easier to simplify a problem like 3 over 5 plus 2 over negative 5 if you use another form of the rational number. So here, they've just rewritten 3 over 5 plus 2 over negative 5. It's easier to think of that as 3/5 minus 2/5. So popping that negative in front of the entire fraction, okay, preceding the fraction. This concept is especially helpful for simplifying rational expressions with denominators that have opposite binomial factors, such as x minus 4 and 4 minus x. And we started looking at some of this both in 13.1 and 13.2. Factoring -1 from one of the binomials and using an equivalent rational expression allows you to combine expressions with opposite binomials in their denominator. So right here we have 3 over x minus 4 plus 2 over 4 minus x. There's opposite binomial factors happening here. So we kept the first one the same, 3 over x minus 4, and in the second factored out the -1 because if we start with 4 minus x and we factor out -1, that gives us -4 plus x. Okay, that gives us -4 plus x because -1 times -4 would be +4, and -1 times x would give us -x. Rewrite that -1 times x minus 4. And now, all of a sudden, we have x minus 4 and x minus 4. Now, we've got this negative here. Okay, we've got this negative here. So what we're going to do is we're going to take that negative that's down there in the denominator right now and put it preceding the rational number, which actually then gives us 3 over x minus 4 minus 2 over x minus 4. Okay, now we have common denominators, and all we have to do is 3 minus 2 is equal to 1 over x minus 4. So let's see that play out in example number 6. We have 4x over x minus 7 minus 3x over 7 minus x. Right now, we do not have common denominators, okay? But we should notice that our denominators in both of these have opposite binomial factors. So what we're going to do is we're going to factor out -1 from the second example. Factor out -1 from the second example. Not second example, second rational expression. So what we end up with, I'll just pop it over here so that you can see what's going on. I'm going to factor out -1. That's going to leave me with -7 plus x. And now I'm going to rewrite it just so I can see it a little easier. X plus -7 or x minus 7, they mean the same thing, okay? So now what I end up with is 4x over x minus 7 minus 3x over this -1 times x minus 7, okay? I'm going to take that negative and put it preceding this entire rational expression. So what's going to happen in this case is I'm going to have 4x over x minus 7 minus 3x over, and I'm just going to write x minus 7 and forget writing that -1 in front anymore because I've moved the negative. So really what I have is 4x over x minus 7 minus a negative gives me plus 3x over x minus 7. Now, common denominator, x minus 7, like terms on the top of 4x and 3x. 4x plus 3x is 7x, 7x over x minus 7, and that is as simple as we can make it. And then we're done.